there's a problem up on the board here. This one is for you to try. The directions say to evaluate this derivative. Now, this is just a sum of multiples of powers of x, but not everything is written as a power of x. So before you take the derivative, you're probably going to want to rewrite the function, remembering to rewrite reciprocals using negative powers and rewrite roots using fractional powers. So go ahead, pause the video, give this one a try. Welcome back. As I said, the first thing we're going to want to do is rewrite this in a friendlier form where everything is just a multiple of a power of x. So I'm not yet ready to take the derivative. So I'm still going to write that d by dx, that derivative operator. All I'm going to do is inside of these parentheses, I'm going to rewrite the function. 3 over x, that's 3 times 1 over x. But I can rewrite that reciprocal as x to the negative 1. So that's 3 copies of x to the negative 1. Plus 5x to the 6th, I don't think I really need to rewrite. I feel okay about that. Okay. Now, negative 2 over root x. That's minus 2 copies of 1 over the square root of x. That's negative 2 copies of x. Now, because it's in the denominator, it's a reciprocal. So we're going to have a negative exponent, and a square root is the fraction 1/2. So this piece becomes negative 2x to the negative 1/2. And then I've got 6 copies of the square root of x cubed. So that's going to be x. Now, when I have something like this, I'm going to have a fractional power. The denominator tells me what root we're taking. I'm taking the square root, so that's a 2 in the bottom. The numerator tells me what power we're taking. We're cubing x, so that's to the 3rd power. Okay. So x to the 3/2, here we've written that as the square root, because we've got the 2 in the bottom, of x cubed. I'll just remind you, it doesn't matter what order I do the root or the power in. So if I wanted to, I could say that's the same as the square root of x cubed. Both of these expressions, they're equal. Both of them I would rewrite as x to the 3/2. All right, now that we've rewritten all of our terms, we can go through and just apply the constant multiple rule, the power rule, and then the sum and difference rule. So here, I'm going to take that negative 1, bring it down, multiply it by the coefficient that's already there. So I get a negative 3. X to the 1 less power. So negative 1 minus 1 becomes negative 2. Plus, bring that 6 down, multiply it by the 5 that's already there. So I get 30. X to the 1 less power is x to the 5th. Minus, I'm going to take that negative 1/2 and bring it down and combine it with the 2. That's going to give me a negative 1. Subtracting a negative, that's going to become a positive. So it's just 1/2 times 2 is 1. X to the, now the exponent's going to be negative 1/2 minus 1. And of course 1 is just 2/2. So that's negative 3/2. Plus, take that 3/2, bring it down. So 3/2 times 6 is going to be 9, x to the 1 less power. So now that's 3/2 minus 1 is 2/2. That's going to be x to the 1/2. All right, just one note on the notation. Do be careful that if you haven't yet taken the derivative, you indicate that you're still doing that. You don't want to leave that out and say that this function is equal to its own derivative. It's not. The derivative of this function is the same as the derivative of this function, which is this function.